Hi, I'm Alex Gatch. I'm one of the fish biologists at the U.S. Fish and Wildlife Service in our Lower Great Lakes Fish and Wildlife Conservation Office. And today I'm going to be presenting on a new study, one of our pilot studies, looking at lake trout spawning on a constructed reef in Lake Ontario. And I'll leave my contact information here and then again at the end of the presentation. So if you have any questions, feel free to reach out to my email, or you can follow along on this project on my ResearchGate as well. And I'll start off giving you just a brief introduction to lake trout restoration in Lake Ontario for those that may not be familiar with this subject. Lake trout are native cold water piscivore. They're native to Lake Ontario, but unfortunately in the middle of the 1900s, they're extirpated from Lake Ontario due to a couple different factors, including overfishing by commercial fishers, sea lamprey predation, and then some critical habitat loss as well. But there is a success story with reintroduction. So efforts by the United States and by Canada has been able to increase the abundance of hatchery-reared adult fish in Lake Ontario. So this figure here from Brian Lantry et al. In 2021 shows you the relative abundance of adults with that shaded line in the background there. And what we see in 2021 is relative abundance is mirroring those in the 1980s and 90s, where there was a large adult stock in Lake Ontario. But what I do want to point out here is that the black line in this figure shows wild fish. So these are wild adults or putative wild adults, fish that don't have coated wire tags or fin clips. And what we see is that annual recruitment is around 3% there. So the wild stock or the wild reproduced fish, there's only 3% of those in the stock. And so what this tells us is that there's a bottleneck occurring for wild recruitment, and we don't really know yet where that is occurring. But this study is kind of a pilot study, the one I'm going to be presenting today, to start to look at some of these questions. And so researchers around Lake Ontario have been talking about this impediment to wild recruitment happening for quite a while. And when we look at this conceptual diagram of where we might be seeing the impediments, we see that the stocked fish or the hatchery-reared fish really have great survival. So fish that are stocked at age 1 from our hatcheries survive quite well to adults, and we see both of those reflected in our annual surveys. And so the impediment is based on this data is probably not happening from age 1 until maturity. When we look at wild fish, we very rarely see wild adults in our surveys, and we rarely see wild juveniles, but in the last few years we have been seeing spikes in certain areas of the lake. So this kind of tells us that the impediment is probably occurring at this early life stage, so between the eggs and the post embryo stages, and this is where we're going to start focusing our research in Lake Ontario. And based on our annual surveys and the life stages that we collect, we're really hypothesizing that the impediment to natural recruitment is occurring at early life stages. And so we have a number of hypotheses that are laid out here of what might be affecting early life survival. And I'm not going to go into those today, but really the focus point here is that our annual surveys really only targeted adult life stages, so using bottom trawls and gill nets. And what we're trying to do is start to shift to, or attempt to shift to, surveys that are going to target these early life stages, which is very difficult. So lake trout spawn in late fall, and their eggs incubate over winter and hatch in early spring. So these are times where it's pretty nasty on the lake. There are large waves and storms. There's ice formation, and it's very cold out there. And so we need to start focusing on finding study sites to study these early life stages that are safe and are where we have access to during times where we don't really want to be on Lake Ontario. So finding these sites that are going to be safe to work on is kind of the impetus for the work that I'm going to present today, and one of the pilot studies that we're starting at Fish and Wildlife Service. So in this figure here on the bottom right, you see from Fitzsimons 1995, it shows historic spawning sites around Lake Ontario. And this red X is the site that we're going to be talking about today. So this is called Olcott Reef. This is a constructed reef that was built in the 1980s. And its sole purpose was for angling for lake trout and also for reproductive habitat for lake trout to spawn over top of. And so the great thing about this site is that it's very close to shore. It's within a quarter mile of the shore, and it's also within a mile of one of the major ports on Lake Ontario, so it's very easy access for us in the wintertime. This reef was built in 3 different stages. So the first was large boulders made of shale, then concrete blocks that were left over building materials were added to the reef, and then finally some more natural substrates as limestone cobble was added in the later 1980s. And like many of the constructed reefs in the Great Lakes, there's a very short period of research and assessment after the reef is built, and that's usually just because of funds and timing and the interest in these projects, where there aren't too many long-term studies of what happens to these structures 20, 30 years down the line after they're built, and if there are lake trout still using these. So the latest research on this reef was in the 1990s, specifically in 1995. Haynes et al. Collected lake trout in gill nets and also collected lake trout eggs over top of the reef, and they saw that there's a relatively large number of lake trout using the reef, and they were able to collect eggs, so they were actually spawning on the reef as well. But since 1995, really the status of the reef is unknown, and we don't know if lake trout are still using this area to spawn. So the objectives of this pilot study were really just to determine the current conditions, so if there's any degradation on the reef and kind of what it looks like now, and then also to determine if lake trout are still using this reef structure as spawning habitat. So if both of these, if we're able to come up with some answers to both of these objectives, this could potentially be one of the sites that we start doing some early life survival surveys on. And over the last 2 years, in 2020 and 2021, we've had limited access to this reef just because of COVID and us being allowed to get out on the water. But we were able to get a few things done on the reef. The first, to address our first objective of looking at the structure, we were able to assess benthic substrate condition with both our Norbit multi-beam and our side scan sonar to make some bathymetric maps. We also got some hands-on data from scuba surveys, so taking videos and some measurements around the reef as well. And to look at our second objective of seeing, our lake trout still using the structure, we wanted to determine the presence of adult lake trout. So in 2020 and 21, we took a single day in each one of those sampling years to do some gill netting at what we would consider the peak of the spawning period, which is early November. And we also tagged a subset of the adults that we collected with gill nets with acoustic transmitters in both 2020 and 2021. So that data I'm not really going to be able to present yet today because it takes a full year's worth of recording before we can look at any data there. So that will soon to come next year. The first year we can look at that data. And then to confirm that lake trout were not just there, but we're also using the spawning substrates, we collected eggs. And we did this with scuba observations, so actually physically looking for eggs with scuba surveys. And then we also used Horns, egg traps developed by Horns et al. In 1989 to collect eggs that had been deposited on the reef. And those egg traps were only set in 2021, and they were set for the entire month of November. So any eggs that were deposited throughout that month were hopefully collected by those egg traps. So now we can take a look at what we found over the last couple of years. And this picture is just a simple bathymetric map of the area of the constructed reef. So you can see that the surrounding water is about 20 feet deep, and that benthic substrate is really just bedrock, which we'll show in a little bit here. When we look at the 3D maps, you can see that the reef is about 5 feet tall at its highest point. And really only that section of limestone cobble is able to be identified in these bathymetric maps, which might suggest that the rest of either the cinder blocks or those limestone boulders have either kind of been moved from the area or have sunken into the sediments around the area as well. Our scuba surveys were a bit more telling of what the actual substrate looks like, other than those side scan images there. And each one of these panels is of color is a different section of the reef. So this yellow is the red shale rock. You can see there are still large interstitial spaces there created by those large boulders. So that habitat doesn't look too degraded. It actually looks pretty good. The cinder blocks are kind of a different story. It looks like there's quite a bit of degradation from sediment and some of those descended mussels as well in that orange panel. And then the red panel is really the lion's share of the constructed reef. And we see that there are clear interstitial spaces in that reef still. There's quite a bit of descended mussel fouling there, but it doesn't look like there's too much sediment fouling. And then we look at the area around the reef. So this is the picture at the top left corner here. We see that most of the substrate around the reef is either sediment or mussel hash, which is just crushed descended mussels. And so this really doesn't look like a habitat that would be suitable for lake trout egg incubation. We were lucky enough to dig up some historic photos of when the reef was first built in the 1980s to kind of compare in quality of substrates from what they were to what they are now. And what we see when we look at the shale area, that area with the larger boulders, is that there's been, quite a bit of colonization from descended mussels, but there's still some of these clear spaces that eggs can incubate in for lake trout. So, the quality of this habitat may have degraded here in the shale area, but it still looks like an area that would allow for successful incubation of lake trout eggs. When we look at the cinder block area, however, this is where the majority of the degradation has occurred. So in 1981, you see you see clean cinder blocks without any degradation. In 2022, we see that those cinder blocks have been heavily degraded by both sediments and descended mussels. So maybe the quality of this habitat isn't as great for incubation of lake trout eggs. Now, unfortunately, we don't have pictures of construction of the limestone reef in the 1980s to compare to today's pictures. But what we can see really is that the degradation here is mostly colonization by descended mussels. And the other form of degradation that you don't really see from photos, but you do see in the videos, is the presence of egg predators like round goby. So within each one of these interstices here created by the limestone, there's anywhere from 3 or 4 to a dozen round gobies in each one of those cracks and crevices, which may mean that egg predation in this area is quite severe by those predators. We also found that there were adult lake trout in the vicinity of the spawning reef during November. So we were able to actually watch fish fin at the surface and jump out of the water just above the reef, which was pretty cool to see in November. We also observed many lake trout swimming around the area and on top of the reef while we were scuba diving. And our gill nets were able to collect 36 lake trout in 2020 and 3 in 2021, which was pretty great because these gill nets were only set for 2 hours during the middle of the day when lake trout would easily be able to see the gill nets, but we were still able to collect quite a few lake trout in the area. And that kind of suggests that there are, a number of adults that are using the spawning area. And so of those 39 lake trout that we collected, we tagged 18 of them with acoustic transmitters. And you'll have to stay tuned to the next couple of years to see, the results of that data as we still develop our acoustic array to kind of look at fine scale movements around the reef area. We also confirmed that lake trout are spawning on this substrate, which is really great to be able to see some of these eggs while we were doing our scuba surveys and also collecting those in our egg traps. And so something that we noted while scuba diving is that we saw a number of lake trout eggs within the lake trout egg traps during our scuba surveys. But when we brought those egg traps to the surface at the end of the month, we only collected 3 total eggs. So what we think was happening is either there was predation within those egg traps from some of the smaller round goby, or more likely when we pulled those traps up to the surface, we were losing eggs as they're pretty close to neutrally buoyant, so the eggs may have floated out of the traps while we were messing around on the surface. It's also interesting that some of the lake trout that we caught in gill nets were ripe females, so when we brought them on up to the surface of the water and on the boat, we did notice quite a few females that had eggs expressing at that time of the year. So that was another indication that they were actually there to spawn. Given the results that we've seen in the last couple of years from studying this site, we can say that we've addressed our first and second objectives here, and really we've seen that Olcott Reef is degraded in various different ways by invasive species and sediment infilling, and that degradation is not uniform over the entire reef, where some sections of the reef are more degraded than others. And what we really don't know is how this degradation is affecting survival of those incubating embryos. So we know from other species such as walleye that siltation can cause reduced hatching success while those eggs incubate, but we don't know if this is similar for lake trout eggs, though we can predict that it probably is, since lake trout eggs incubate for 5 to 6 months at a time. So any perturbations during that amount of time could have effects on survival. We're also looking at how invasive species can reduce survival. So this picture in the bottom right-hand corner here has a number of round gobies that are circled with those red circles there. We have many egg predators in this area, and we know from some of Ellen Marsden's work that round gobies do consume lake trout eggs. So we'll be designing future studies to look at that. We also know that draceniid mussels are very sharp, and that egg abrasion does occur, which can cause mortality of some of those embryos. So we'll be looking at some of these effects in the future as well on this site. And then, not to put the cart before the horse, really before we know the effect of degradation on these spawning habitats, but there are methods to remediate different spawning habitats, such as cleaning off substrates from silts and mussel hash, or ultimately augmenting more habitat, so adding substrates to the existing reef. Moving to our second objective, we were able to confirm that lake trout are still spawning on Olcott Reef in 2021 at least. And so we don't know the extent of the usage. We don't know how many lake trout are using this area. We don't know the egg deposition rates or the hatching success. And so that's really the next move in our development of this project, is start doing some spring sampling to confirm the presence of post-hatch juveniles. So seeing what the hatch rates and the survival rates are on this structure will be very important moving forward. Also, our telemetry in the next couple of years will be able to be used to answer some more of these spatial questions. So some fine-scale acoustic telemetry from Lake Huron has been used by Thomas Binder's crew in Lake Huron, and they're able to really pinpoint areas within spawning reefs that lake trout are using, and try to look at some of the conditions in those areas that might attract lake trout. So that's something that we're hoping to do as well. And really, so I just want to share the takeaway from this pilot study here, and that's that Olcott Reef has the potential as a study site to test these mechanisms for early life survival. So the site proximity to shore is going to be great for some of these late in the year and early in the year sampling periods. And we also know that this is an area that's still being used by a number of lake trout, and that's confirmed by their eggs being present. So this is an exciting time in our research in Lake Ontario, so we can start to shift some of our efforts from the adults to these early life stages. And it looks like Olcott Reef has some great potential to be one of the study sites moving forward. So thank you very much for listening in today. And if you have any questions, feel free to send me an email, and I'll get right back to you. Thanks.